In this section, I'm going to be talking about outliers. We've been able to ID the outliers and erroneous data by using descriptive stats and visualization. And just to repeat, an outlier is a value that is extreme or lies outside other values in a dataset. As mentioned in the past, outliers can influence models, and with histograms or summary statistics or even scatter plots can help identify outliers and our data quality issues. And it's up to the analyst to decide what will be considered normal and abnormal when it comes to observations that are singled out. As a note, outliers should be investigated very carefully since they contain valuable information about the process that's typically under investigation or the data gathering and recording process. Before eliminating right away, it is very important to understand why they are there and why they appeared, and if similar data will continue to appear as an outlier before labeling it as a bad data point and dropping. I'm going to be using multidimensional data set to look for outliers. The data that I'll be using is from Gapminder socioeconomic data, and you can see the links to the page on the screen. And if you want to read up on Gapminder, you can do so by clicking on the links. Now, just as a summary, Gapminder is an independent Swedish foundation with no political, religious, or economic affiliations, and it fights devastating misconceptions and promotes a fact-based worldview everyone can understand. Now, the data will include the following variables: country, continent, year, life expectancy, population, and GDP per capita. First thing I want to do is import the modules and load up my data frame by reading from gapminder underscore data.csv. And the next step is I would like to create a 4x4 correlation matrix. As you can see here, there is a moderate relationship between life expectancy and GDP per capita, and looks like year and life expectancy. Moderate positive correlation. Next, I'm going to rename my columns and at the same time use my pandas data frame describe function to generate descriptive stats, which will include summaries of central tendency, dispersion, shape of the dataset distribution, which will definitely include my percentiles. Great. So as you can see here, the count, we have about 1704 records. The data set seems to include the years 1952 all the way to 2007. And it looks like the life expectancy for the data set, we have a range from 23 to about 82. As you can see here, from the data frame, the columns, there's a country, continent, year, life expectancy, population, GDP per capita, which is affirmed over here. As you can see, there's a country, continent, year, life expectancy, population, and GDP per capita. Now, out of curiosity, I would like to take a look at a box plot of life expectancy versus continent for the years anytime after 2005. So I'm going to go ahead and copy and paste some code. And voila. We can see over here, we have life expectancy versus continent. And we're able to right off the bat see that the life expectancy in Asia, Europe, and the Americas and Oceania is a little bit higher than the African continent. But of course, my whiskers are a lot broader when it comes to the African continent, with a maximum that's almost in line with Asia, Americas, and Europe, but on the flip side, with a minimum that's a lot lower. And if you recall, my maximum over here is Q3 plus 1.5 times IQR, which is my interquartile range. And of course, on the flip side over here, my minimum typically is Q 1 minus 1.5 times IQR. And as you can see here right away, we have some outliers when it comes to Asia and the Americas when it comes to the life expectancy. Now, just for fun, if we wanted to also take a look at a box plot of GDP per capita over here after the year 2005 versus continent, you can see here that the GDP per capita is higher in Europe and Oceania, and definitely lower in Asia, Americas, and African continent. And as you can see here, we have a few outliers, of course, where the GDP per capita is somewhere between 10 to 20,000, and in the Americas, it's between 30 to about 44, 43,000 or so, just by taking a look at it visually, of course. And just if you recall, in one dimension, when you have values that are more than 2 or even 3 standard deviations away from the mean, they're usually tagged as outliers. So we've seen this before in our previous lectures. Now, another way to look for outliers, and especially multi-dimensions, is through the use of a scatter plot matrix, which is simply just a collection of scatter plots organized on a grid. So there is a very handy function, a Python function called perplot, and it's from the Seaborn library, which will create a scatter plot matrix. So I'm going to go ahead and copy and paste some code. And the variables that I'll be using is life expectancy, population, and GDP per capita for values for any time after 2000, with of course my hue is going to be my continent here. So I'm going to go ahead and run it. Excellent. So as you can see here, I was able to successfully generate a scatter plot matrix. And again, my features over here that I've selected is life expectancy, population, GDP per capita. Of course, I can't fit it all on one screen, so I'm just going to right click, open a new tab. It's a little bit easier to see. Life expectancy, population, GDP per capita. And as you can see here, when it comes to my diagonal, you can see the histogram for life expectancy, population, and GDP per capita. So again, this is my univariate distribution of my variable. So in this case, life expectancy. Over here, population, population. And last but not least, GDP per capita, GDP per capita. It is informative, but at the same time, hard to understand with the breakdown by continent here. And as you can see here, when it comes to my skew, the distribution, especially for population and GDP per capita, population, GDP per capita, is skewed to the right. So I'm going to change it slightly where I would like to now, instead of a histogram, I'm going to try to make a different type of plot for my diagonal subplots. In this case, I'm going to try to plot my kernel density estimate, which is a little bit nicer for me, especially to visualize the distribution, especially for the dataset observations. Now I'm going to perform one more trick here. As you can see, since the data is skewed to the right, and at the same time, these are pretty substantially large values, I'm going to log transform these columns, especially the population and GDP per capita, to better represent the data visually. So what I'm going to go ahead and do is copy and paste my data, take the log of the population, take the log of GDP per capita, and create a pair plot for the years after 2000. Here we go. So since this doesn't really fit in one screen, so I'm going to go ahead and change my height to 3 and right click, open a new tab. And as you can see, been able to generate a very nice pair plot. And right off the bat, you can visually see the trends of a positive correlation between GDP per capita and life expectancy. So GDP per capita and life expectancy, which suggests that people in richer countries live longer. And you can also see that Oceania and Europe tend to have the highest life expectancy and highest GDP, which is also shown here and here. While Asian countries seem to have the greatest population. Visually, this is very informative. This concludes our section on outliers.